Hey, good evening. So I guess it's morning in your time. As Jeff said, so my name's Anthony Walker. I am currently employed as the Director of Health and Fitness for the ACT Emergency Services Agency. Part of how I'm going to go about going with this is my background particularly has been particularly within a fire service. I've been an operational firefighter for the last 15 years, but we're currently in the space in Australia where we're starting to move into trying to use science to underpin some of our decision making when we look at how we engage the well-being and welfare of our firefighters. It does spill across other areas. One of the things, you're all postgrad, so it's probably no real secret to you that everyone sort of likes to do sports science to work in elite sport. But particularly here in Australia, that's simply not where the jobs are anymore. So it's more in this occupational world. So bear with me with the tech, but we will see how I get that to move. Perfect. Okay, so just a bit of a sort of a background, a bit of a heads up, sort of where we're going. One of the things, particularly for those of you who haven't worked within these emergency services type agencies, is it's one of those things that it's not really a job you can take that seriously. If you take it seriously, you end up sort of damaged. And some of the stuff that's there, yes, there's a lot of exciting things that happen, but there's also a lot of hard work that goes into it. So yeah, this is sort of the nonsense I get from my police. Well, they're not really friends, they're colleagues, I guess. But you'll see sort of the banter that's there, and it sort of sets the tone for where I'm going with this. It's a serious job with serious outcomes, but to some extent we've got to take it for what it is and realize it is there. By the same token, that's kind of the stuff that goes back the other direction. So very quickly, sort of just again for those of you I haven't met, Canberra is bang in the middle of, it's in the southern part of Australia. Summer temperatures are over 40 odd degrees, and the two pictures you can see on the side there, that's Parliament House here in January. And then the pictures down below is what I saw off my balcony just to the south of Canberra. So we had massive bushfires happening here this year, at the end of last year, which will dominate our landscape, and it's currently dominating we're in the preparation phase where within Australia to the north is where we start seeing our bushfires, which is happening now. And as summer happens, you'll see it start to move down through down the states and then around the corner around to Western Australia. So yeah, it's hot, 40 odd degrees in summer, and where we are here in winter, it's below zero. Jeff's explained my PhD was actually maximising safety and performance of Australian urban firefighters working in the heat. I was lucky. Yeah, most of you have got horrific PhD stories. I didn't have that. I got lucky. I had a chief officer at the time who was very driven by putting evidence behind the decision making of what we do. And basically I had everything I needed. It was great. I had access to resources, I had access to firefighters, I had access to funds. So it's something that's on our radar here of our chiefs. It's just very, very hard to get in place for any of you who've worked in that sort of policy role. As I said, 15 years I've been a station officer. For an American audience, it's like a lieutenant and a captain, but for those of you who have worked with fire services, it's kind of like a watch manager within your fire services. And as I said, my role is the Director of Health and Fitness. We're a little bit unique in Canberra in that our fire service isn't a standalone agency anymore. It works to a commissioner. So I have responsibility across 4 operational services, that being fire, our ambulance service. We have our rural fire service and our state emergency services, which are both volunteer organisations. They present a number of unique challenges that we don't have with our professional organisation. But when you see what you see on the news, where you see the people out fighting the bushfires, they're generally volunteers in Australia. They make up probably 80 to 90% of our firefighting capability. So they present a lot of unique challenges we have to be across. One of the concepts here is, and this kind of underpins my whole talk and where we're going, is exactly that concept. It's hard. What we do to our people, what we expect them to do. We're pushing our retirement age out. I know you're doing the same here, but for us, it's 60, 63 before I can access superannuation, or the age pension here is now for 70-year-olds. So, it's not a job for old people, but unfortunately the reality of our situation is that our people are going to be working for much, much longer. 15, 20 years ago, they were retired at 55. So we didn't have that anymore, but the people making the decisions around our pension age and around how we manage our aging workforce, they're office-bound people. So it's very hard for them to contextualize the risks that we offer, that we're asking our people to go through. So again, for those of you who are not really coming from an emergency services background, in terms of a firefighter, they fall into two broad categories. And what they basically are is, you'll find that they are either an urban firefighter, which is what you see running around your cities. They're tasked with a lot of different things now. Firefighting is only about 5% of our workload. The bulk of our workload now is along the lines of crash rescue, all sorts of random jobs that you wouldn't come across, a lot of education type stuff. So that's what our urban guys do. So when you're looking there, that's the picture you'll see with the SCBA on the back. So that's a self-contained breathing apparatus. And we also have wildland firefighters. So I'm not sure if you call them wildland or bush, but essentially they're the same thing. So you can see the American type firefighters is the top picture, and then you see what an Australian wildland firefighter looks like. Worldwide firefighters, the bulk of them are volunteers. I know that within Britain you have 3 tiers where you have a fully professional service. Then you also have your retain, we call them a retained, so they're your on-call firefighters. But we also have the volunteers, and just the sheer numbers, as you can see on the side there. So the professionals are 3,500, and there's 72,000 volunteers, and that's just one state. So New South Wales is our biggest, but it's purely down to sustainability of the model. Many of our small towns, they can't sustain full-time firefighters. So these are people, and when you're looking at research in this space or activating in this space, is that these are people who do this on their days off. So they may go to work they might do an 8-10 hour day of work, and then that night they'll be out fighting fires, or they'll be cutting down trees, or doing all sorts of things. So we're acutely aware that fatigue management is something that's a real issue in our world, and it's something that happens in all shift work. So anybody who's working with any shift workers will know this. But it's unique for our volunteer firefighters and our volunteers, so our state emergency service rescue people, in that they will work all day and then they'll come to work at night. So, and during our peak season, they'll do massive hours, and it's more dumb luck than good management that they don't tend to get hurt. But when you see that we do lose firefighters every year, and a lot of those come down to poor decision making on the fireground, which you can directly link back to fatigue. Or we also have heart attacks, which just come from the environment and lack of physical condition for our people. One of the things here as well, and this is kind of a really telling sort of thing if you can read it, and it says that, essentially we're the catch-all for everybody. So, when people make a phone, when you ring, I don't even know what yours is, 999, I guess it's 000 here in Australia. People don't care who's coming to help them. They simply don't. They just want somebody on the day to show up, fix what problem that is, and then move on. But as you can see with that Chicago Fire quote, is that exactly that. So it's not a case of just send me a couple of dumbass fireys. They want people who can come, they're professional, and they can roll in with a lot of things and solve problems fast. So what we're looking for is, we're looking for people in this world particularly who not only have a number of highly trained skills that they have to maintain, but they also have to be adaptable. The fire truck, we talk to people about it. We essentially, it's like a big toolbox. It's what you do with the tools that are in that toolbox. Without that, they're essentially irrelevant. But you'll see just on there, you see just the breadth of things that they do. So the EMT, so that's a big role for us now. We attend a lot of heart attacks. We attend a lot of other things, that because our ambulance services, our communities are getting overwhelmed with aging populations. Even before COVID hit and sort of caused us grief, our health system is just overwhelmed. So the fire service is starting to move into those spaces as well. just because they're sitting around, and they've got the capacity to assist. So the gear they wear, again, this is for people who haven't really worked in this environment before, is what they have on them is that self-contained breathing apparatus in any sort of thing. But basically what it is, it works on a positive pressure. So what that does is you basically, the aim of the positive pressure for the non-engineers is essentially, if that mask fails, what it will do is it will default to pushing air into the mask. That's a massive safety feature. Just purely, you don't want it in the environments that they're operating in. You don't want them to get gases or smoke into that mask. The problem with that, though, as you can see down lower, is with the pressure that's there, you need to create a negative pressure system within that mask. So to activate it, we talk about the first breath. So it's like and that will activate the mask. But what it does is to draw that pressure in, you need to create a negative pressure gradient in the mask, which will then basically mean that you require a 20 to 30% elevation in your VO2 max, or your max aerobic capacity or power, just to be able to keep up with your normal amount of work. It's a big issue. Yeah, and this is where when we go, some of you are probably working in the area of creating fitness standards, fit for duty, or even strength and conditioning programs for these guys and girls. You have to be aware that we set a benchmark of where we think it needs to be, but you need to give them that buffer so that when they're operating in these environments, that's what's going to keep them safe. Basically, as you can see there, it's about 12 kilo for the 300 bar, 6.7 litre cylinder. I'm not sure what the British Fire Service do, but I would assume it would be something close. So when you start to add these together with all the other gear as we go through, you'll start to see there's a big level of weight and things that are on them that you have to also factor in when you're developing programs for them. The operational wearing time, and this feeds into both fatigue management, heat stress management, and operational capability, is highly variable. So depending upon we expect 20 to 30 minutes for a cylinder, but some of our people will suck down a cylinder in 5 minutes, 10 minutes. Other people will take 45 minutes. It's also variable upon what they're doing. So if they're just standing pointing a hose at a building, they're probably going to be at that 30-minute mark. But if they're actually in aggressive firefighting mode within a building, it's going to be a lot lower. So not only do we have an issue with how much air they have, we need to understand when we task them what they're going to be doing so that we can then be building capacity for backfilling. Obviously, the fitter they are, the better. But we also need to understand, how do we develop a program for these guys and girls that not only they are aerobically very fit, but how can we reduce that mechanical load on them so that we can extend their working duration as long as possible. It's another challenge within our world that we have to really capability. In terms of our turnout gear, I assume you're calling yours the same thing. To protect from heat and flame, you've got the heavy protective equipment. Down below the bottom there, that's my current fit out in my guys. It's basically what it is. It's comprised of 3 layers, and one of the problems in the occupational world is we very much work within a work health safety framework, which means that at all times they have what they call a hierarchy of controls, and at the top of that, the first thing we try to do at all times is eliminate. So that's eliminating risk. To do that, what we've done is within our PPE, we've created something that has 3 layers on it. So we have an inner layer for comfort, which is just like wearing a doona. Or your equivalent. What it also has a flame resistant outer layer. So it's a Nomex or an aramid fiber. But what's now within these things, and this has changed the nature of firefighting itself, is that it now has a moisture barrier in it. So Gore-Tex is the normal go-to, and part of that was to do with protecting it from steam burns. So as you can see in the top there, that's how we fight fires now. We don't just shoot water through the back door and hose your gear out the back. What they're doing there is they're actually throwing the water up into the air. It becomes an aerosol, and because of the nature of it, the water as it expands takes heat out of the environment, which then will put the fire out. So when we actually get to the fire, we're using very, very limited amounts of air. of water at the end. What that risk, though, as you can see, is their hands are up high, and then there's a potential for steam burn. So they've built in these Gore-Tex membranes to stop that. What that's also done from a knock-on is, though, it's created a humid microclimate where they're operating in. And interestingly enough, we actually see more burns as a result of this when they've got that humid microclimate, when they then go and lean on something hot, and you'll then see a burn happening to them as well. So we're seeing these unintended consequences of trying to fix a risk. The big thing as well, and I'll touch on this later, is we're really worried about what the chemicals ingress into the body is now. So if you look at that fire up in the top there, you think a modern house, it's all plastics. 20, 30 years ago, houses never got to that extreme level we see now, whereas most house fires we roll into with 7, 8, 9 minutes response time, it'll be through the roof. And because it's all plastic, so there's a lot of chemicals going around, and we're now starting to see, through looking at the medical standards and what's happening, we're actually starting to see a lot of cancers occurring. So we're trying to protect them. On their head, you'll see what we call a flash hood. Again, that's just to protect, that's purely to protect your ears, those sorts of stuff in those really hot environments. And that's caused a knock-on as well, in that when you talk to the firefighters of old, one of the keys for how hot an environment was when their ears were burning, they knew that it was hot and they had to come out. Our guys and girls now don't have that. They don't have that sensory input that they used to have, which means they'll tend to get themselves in they can get themselves in a dangerous situation before they know they're in trouble. It also means that they're going to get a lot hotter because they go further into the environment that they have to then retreat from. They've got thermal protection in their gloves, very thick. And basically the two knock-on effects of this whole PPE is, obviously there's a massive issue with thermal loss. So there's nothing's exposed to the environment. And even on a mild day, like a British summer, you would find people will just fall over on a 20-degree day just because there's no potential to dissipate heat. But it also, because of the nature of it, it also reduces your movement efficiency. It's bulky, it's heavy, and it just slows you down, and everything's hard. So it's another thing we need to be concerned on. The boots that are there as well, and this is something we looked into. One of the things we know is that firefighters particularly get a lot of lower back injuries and upper body and upper leg. And what we looked into from there is we looked at the boots as a potential contributor. So if you look at how they're designed and based on the standard, so it's an ISO standard and also an EU standard, you'll find that they're generally pretty generic in what's there, and that they need to be flame resistant. They need to have an inflexible sole for impact protection. So when you're looking, you think what we walk across, it's glass, it's nails, it's all manner of things that are there. That's there's a rigid barrier there. So the more modern ones now are a bit more like a Kevlar. So they do have flexion in them, but what's generally running around at the moment, you'll find, would be a steel insert or a plastic. They need to have toe protection as well, so it's got a steel cap on there. Again, it could be a plastic, but essentially what that does, it also reduces movement within that boot. It increases rigidity. There's a rigid ankle. So again, going back to a work health safety. So if on any given day you get someone knocking on your door from a fire service, any occupational environment with a problem, we need to understand or start to conceptualize what could be the knock-on effect of you doing something. So firefighting boots of old were like a gum boot. So basically they were flexy. There was very little in terms of ankle. So what used to happen was firefighters used to roll ankles a lot. Working on those unstable environments, and those used to get a lot of ankle injuries. So in order to fix that, again, going to the hierarchy of controls, eliminate is the first one, and somewhere along the line, they basically locked in the boots, so they're now like a ski boot. Weight of those things, again, they can be anywhere about 5-6 kilos for the pair of boots because of all the stuff that's in them. So when you think in terms of you're adding weight to the end of those levers, so you're creating load at all given times, making it harder. They fatigue quicker. And then what we did here, as you can see on the Vicon measurement system, what we actually looked at what that was doing in terms of the kinematics and the kinetics of this. And what you find there is you've obviously got a significant increase in ground reaction forces. And purely just if you think about force attenuation through your lower body, what that kinetic chain looks like. When we put the rigid sole in, basically there's no potential for any force dissipation, so they basically just thud into the ground. And what we could see was the vector moving instead of up across the knees and where we'd normally expect it for a landing, we would see that driving straight into the lower back. So not only do we have increased ground reaction forces and increased or shorter duration to peak force, we also then saw the reduced ankle plantar flexion as well, which that wasn't to be unexpected given how much rigidity was there. So again, we tried to fix a problem and now we've caused another problem, which is lower back injuries that we never had before. So yeah, these are just other areas that are there. This was my honours project, was in biomechanics. There's a reason I'm a physiologist. I'm nowhere smart enough to do biomechanics full time, but that's kind of what it is. The last bit of real gear that you'll see on them is you'll see helmets. For obvious reasons, this is probably the key bit of gear that we wear, and to some extent, it's a bit of it's almost like our unofficial uniform. It's the thing of pride. You know, I have my first helmet I was ever issued. That's up on my shelf. You know, I've been promoted since. I've had new helmets. It's a bit of pride for our people. And what you'll see there is rotating through them. You'll see the American helmet, the one with the big number 1 on it. The one in the middle there, that's pretty much what your British firefighters will be wearing at the moment. And we've just slid to that motion. The one below it is what I was wearing 6 months ago when I was on the trucks, but now we're onto the top jet style. And then you've got sort of the French, European type ones, which they're just a different version of those jet helmets. They need top impact protection, some side impact protection, but interestingly, within the Australian standard, we don't test those helmets for impact protection on the side, which it's kind of counterintuitive in that it adds another level of protection we'd really like. Protective visors that come up and down when we're doing RAR, so crash rescue type gear. Generally, it's a one size fits all, which this is a big issue, and I'll touch on it a bit later on, but one of the things is we're starting to try and increase the diversity of our fire service, particularly with focus on women. But what we're doing is we're giving them helmets that were built and every other bit of gear that's built with around the standard average male, which is going to be a lot bigger than a female. So we're going to start increasing load on their necks, which there's a long-term fatigue issues, but there's also issues when they're under load, they're moving fast or they fall. So we've got to worry about those. And generally, just for your own benefit, color will generally denote rank. That's just if you ever see them. Again, from my area, which is as a sort of a heat specialist, the issue with the jet style helmets, it's just another level of encapsulation that will create a heat gain. Ours used to be a lot more, so the Americans will allow a lot more opportunities for heat release, but it's just something else we need to be aware of. And in many cases, we're trying to solve a problem that needs to be solved, which is protection. A lot of the time, we're now actually working in the standard operating procedures area, whereby we say to these guys, do you need to be wearing this gear at this time? You know, do you need that level of protection when you're not actually doing that? So we're trying to manage risks now through policies and procedures, which is, when you look at the hierarchy of controls, that's a long way down that hierarchy, and we really shouldn't be playing there. But the problem is the one at the top has actually caused a new issue, but we still need to manage it. So it's retraining our people about when and how to use this equipment. In the broadest terms, what they do, I said they're a catch-all. That's pretty much what they do, but you can capture most of that within their structural firefighting. So that's buildings, it's a fire, it's a house, it's your Grenfell Towers. That's structural firefighting. Your wildland firefighting. I'm not massively aware of what your guys do, but I see those fires you see up the north where they're in the moors, and it's not like the big flames that we see, but your guys and girls are chasing fires underground. They're in the peat bogs and stuff like that. So it's a whole different way of firefighting. Vehicle firefighting, so putting those out, planes, cars, trucks, anything that's got wheels, when you think about a vehicle. And then obviously you have specialist aviation firefighters. It's a whole different type of firefighting. Crash rescue. So, the old cat in a tree, it happens, we do that. But we also, it's vertical rescue. It's rescuing people off mountains. It's water rescue. It's getting them out of lakes and rivers and all sorts of stuff. And also hazardous material responses as well. So in terms of a hazardous material, so that's a level 2 PPE protection in Australia. But what you'll see there is that it's fully encapsulated to the point where there's nothing in and out. It's designed that way, again, to solve a problem, but it causes us big issues. And as you can see from old mate on the side, that's not a pretend photo. That's exactly how much sweat will come out of you. Generally, we can work on a single SCBA, so it'll give us about 25 minutes of work. But the problem is it takes you so long to get in and out of that gear. By the time you've done it, we'll generally twin that. So instead of having 12 kilos on their back, they now have 20 just in the SCBA. Then once they come in and out of that, so they then have to go through a decontamination process where we will connect a line onto them, and they can then be on that line for another hour or two, if that's how it ends up. So within that environment, they can't drink while they're in there. They're getting hotter. The best we can do is just try and keep them cool externally. But think of the thermal load that's starting to go on these guys and girls, and particularly when they're adding dehydration in there, that we have to start to worry about. They cut, carry and use heavy tools. Everything we use is designed for a reason. And modern cars, once upon a time you could get them open literally with a tin opener, but now, because of the level of protection that's in these things, it's great if you're the person in the car that's crashed. But for us to get you out, we need to use a lot heavier gear. So the cutting tools you'll see working on the doors there, they're 20 odd kilos each, and you have to operate them at multiple heights. So you sort of have mid height, you have above your head, and you also have it down around your knees sort of height to be able to do things. Dragging people up and down with those ladders, sliding people, cutting holes in roofs. So there's a lot of heavy gear on top of the 23 odd kilos that you wear before you even get out of the truck. So it really is incumbent on our people to stay fit and healthy. But as an employer, we also have to look after our people. And also we work in all climates. It's not a job where they get to just pick and choose, or they sit in an office where it's 20 degrees every day. They will literally be working where they work. These are North American firefighters. We don't get that in Australia. We more see the stuff down the bottom with the bushfires. That's more our world. Okay, so the main thing as well, and this is kind of, that was just to give you a bit of context around the world what I'm talking about here, is that they're limited by their physiology. So we need to understand what it is about them and how we start to prepare them best to work within those environments. And while I'm focusing on fire, because it's kind of my area, this is equally relevant for military, for police. Even think more broadly. Anybody we ask to work somewhere hot, it could be the guy or girl who's on a lawnmower in the middle of summer on a 40-degree day. It could be someone down the bottom of a mine digging rocks out of the ground. The scope of occupational physiology it's enormous. We like to focus on the sexy firefighting, the sexy, the military, all those glamour type jobs. But in reality, these people they're probably safer than those others who are not really selected for their physicality. So the miners, anybody who works in heat. So you can imagine as much as I can what's there. They're defined by their individual strength and power. Obviously, I've taken this slide from somewhere else, so I apologise. I'm probably teaching everyone to suck eggs here, but we have to focus on strength and power. And in terms of the inherited genetic potential, we're currently fighting against the modern workplace mindset that everybody should be allowed to play in every single thing. So everyone gets to be a winner. The reality is there is a percentage of the population who just physically can't do this job. and we need to be a bit grown up as we start moving forward, particularly as we start to look at diversity and those sorts of targets, is finding those people who have those inherited genetic potential we need and get them in the position. Women can do jobs, men can do jobs. It's an irrelevant argument. It's more we need to focus on what are the traits of those individuals that we need to get them to do that. They're defined by their aerobic power, or the work, is defined by aerobic power and anaerobic power. But mainly the things that define the work is not only the physical environment, but it's also the tasking of those tactical operators as well. So we can manage to some extent some of these people. Some people we just don't put in harm's way. And also how you teach your incident controllers to rotate people through those. The main thing is here as well, and it's kind of a bit of a perceptual thing. It's a bit of a misnomer, and as firefighters, we play on this a lot, as do the coppers, as do the military. And when you call 000 or you're 999 in the middle of the night, there is this perception that this is what's coming to help you out. I still think I look like that, but there's not a chance in hell that's the right thing. But reality is, this is what's coming. They're people who, they may have looked like that when they started out 20 or 30 years ago, but yeah, they've all gone through life. Yeah, they've been injured, and the job takes a toll on them, and life takes a toll on them. They're in their 50s, they're in their 60s, they're doing that sort of stuff. But the reality is, these guys can actually still do the job. They may not do it as fast, but as they get older, they get smarter. So we need to they start to understand. We as scientists like to think we know all the answers, and we can we can study things and we can put data in front of things. But one of the best measures I'm finding, and the longer I do this and the older I get, is that these guys and girls know exactly how to look after themselves. They've been doing these jobs that are really hard on them for a long, long time. We need to start to tap into understanding what exactly have they learned over time, and then translating that research or into our research and contextualizing it. One of the things that people really dislike in these occupational worlds is, nosy, bossy scientists who come in and treat them like we're the smart ones and they're just dumb. And we need to understand and really be aware of the fact that these are the people who do this every day, and we need to be cognizant of that and give them the respect they deserve for the job that they do. So again, this isn't too much. So this was sort of out of my PhD study looking at this. But what we start to see is that we are seeing exactly what we see in the general population. So the top graph there, what we're looking at from our people. So the dark black line was guys from my fire service. The middle one was what they just called an athletic population, and the bottom one was a sedentary population. And the dotted line there, 42 VO2, is what is the current British standard for firefighting fitness. But as you can see there, 25 to 34-year-olds, on average, they're over 50 VO2. That's a bit of a no-brainer. We'd expect that for this population. But as they start to track down within that trajectory, you're going to start to see those people over 55, even just look at the size of those error bars, they're going to just naturally age down below those lines. So how do we develop strength and conditioning programs? How do we target the right people to look after them to make sure that they stay above that line as long as possible? At 55, you've still got 10 years left in your career, and they're damaged, they're injured, they're just worn out. So we've got to work out a way to do that. And within my current role, that's our big challenge, is how we start to design and implement strength and conditioning programs that try and straighten that line out. We know it's going to look like that over time, but if we can flatten it as long as we can, that's the goal. And then we can just try and slide these guys and girls out into retirement, because we don't want them dropping out. We don't want them finishing their career and within 12 months they're dead. That's the worst outcome for somebody, or they can't take their grandkids out or put a boat in the water or do whatever it is they want. This is the new responsibility for us. It's looking at their long-term career, because firefighters don't die in fires anymore. It's that long-term well-being and wellness stuff that we really need to get our head around. And then the one down the bottom is just in absolute value. So it's pretty much the same picture. In terms of strength and power testing, and this is something that's, it's kind of a little bit counterintuitive. And they talk about old man strength, but within a hose drag and a dummy drag scenario, pretty much they're still they're not moving that far within that sort of the hose drag, and it's a power and strength exercise. So this was grabbing a 25 mil hose off the side of a truck on a drum. They drag it. It's a 50-meter drag. They drag to 25 meters, stop all momentum, then they go again. And as you can see, the difference between those 10-year age groups, so we're looking 20 seconds for the 25-year-olds to like 22 seconds. And again, from an academic perspective, that's great. We see statistical significance, but in the reality, does 2 seconds make any difference? And then, no. So we need to talk about meaningful changes in this world. 2 seconds to drag a hose 50 meters, it's negligible. And same with the dummy drag. It's going from 50 odd seconds to 70, 80 seconds. Yeah, it's kind of getting into that world where it's an issue, but is that aging alone, or is that just literally the fact that we haven't looked after those guys? Can we get that back down again through training, particularly as they start to enter their mid-40s, which is where we see all our injuries and our performance declines. In terms of body mass, and this is something we've got to look at our guys and girls, particularly as they go forward. So it's one of those misnomers. So they talk about, you'll talk to these guys and girls and they'll say, look, I joined the job and I was 80 kilo and 20 years later, I'm still 80 kilo. But the purpose of doing this was we were looking at from them is you'll see in the middle there, obviously the BMI is the middle one. BMI doesn't change over time, and that's what they're talking about. They're going, this is great. I haven't dropped any weight. I'm looking after myself, and that they're using BMI as a measure. The fact we even still talk about BMI in these populations is just baffling. But what we tried to really impress on the guys is the top line you'll see is the lean mass decreasing, and you'll see the body fat increasing. It's not a massive stretch to show these guys and girls that you still weigh 80 kilo, but up the top there we look at your waist circumference and you've now gone from sort of an 85 waist to a 95 waist, so you're in bigger pants. So we're trying to educate our people that you've got to keep lean and strong for mass or for body mass to actually be a relevant marker. And that now goes into our nutritional science. How do we teach our people to eat the right foods, particularly when they're working on shift work, particularly when they're stressed? All those other environmental factors that they're dealing with every day is going to create poor food choices, but we need to start to educate them. So there's a role for nutritionists, a big role really going forward. And what we came up with here, this is sort of just a bit of a contextual of what's out there, but you'll see there exactly that. So we've got reduced mobility, higher acute load, greater thermal load. That'll give us higher metabolic costs, which will lead to fatigue. And then from that fatigue, we start to see higher slips, trips, falls. That's our biggest thing. They don't pick their feet up. They step off a ladder 2 rungs too high. The cognitive impairment that comes through heat stress and fatigue, they make bad decisions. So whenever you hear, and I'm not sure how much of your news you'll hear, but you'll see Australian firefighters that get overrun. Their fire trucks will get overrun by fire. They're normally in a really bad spot. They should never have been in the first place. And if they weren't in this fatigue situation, you'd find that they wouldn't be making those poor decisions. So that's there as well. And we see impact injuries. So a tree will fall. My fire service has only had one on duty fatality, and it was a tree in a wildland scenario, a massive tree 45 meters away that actually fell and hit the guy in the back of the truck and killed him. So we see that, obviously that's the extremity of the impact injury, but the question had to be, why was that truck parked there at the time? Why was he on the back deck? So there's all these things that come out of fatigue, and then we have those injuries in that area. We also have that higher chronic load, and this one's sort of, over time, particularly as they get older, we see burnout. We see that compassion type fatigue. They're burnt out. They start to just not tolerate things, and they start really just getting agitated about the simplest things, which will cause us big problems. And then there's motivation issues. They'll get chronic injuries. the niggly knee injury that was there when you were playing footy when you're in your 20s is now a massive problem when you're in your 40s, and you're still got to last another 20 years. So we've got these chronic things we have to start to manage as well. So we need to start to integrate the allied health world into our world as well to help that. And that higher chronic load then leads to poor mental health. So the burnout, the chronic injuries will then start to put them in that spiral of that poor mental health. And the outcome on the side there for everything is reduced career longevity. I keep going back to the fact we need to keep these people alive and moving till they're in their 60s. Should we have them on fire trucks? Probably not. But what else are they going to do? They've done 20 years as a firefighter. That doesn't give you many skills to go out in the normal world. Some of these guys, they use computers once a year, and that's to get their group certificate to get their pay. They just aren't skilled. So we're having to also work now within these environments of how we upskill them for potential future careers so that they can leave in their 40s or their 50s and then move out. Dutch fire service in particular, you're only allowed to do 20 years on the truck and you're done. But the issue is right on day one, they essentially start a conversation with you saying, what do you want to be when you grow up? And they'll then work towards that. So they're trying to take that out of place. There's administrative things we can do with these guys and girls as well. It's a big cultural shift. The families are all tied up with being firefighters, and that's their personal identity. So in terms of the looming challenges that are coming, and for those of you who want to start to work in this space, these are the three areas I think you need to start to think about. Obviously, your aging tactical personnel. It's a big issue. Our fire service is now at about 43, 44 is the average fire service or the average age. New South Wales, which is our much bigger service around the state around us, it's up around 48. And that's just the average there. So you're going to have to start to understand how do we start to manage the aging population, managing chronic injuries, keeping them fit and strong, keeping their diet right, keeping them mentally healthy. Because the other thing is, and there's something that's there as well as this operational experience, we can't afford to lose that. It's a job like many other of these tactical type jobs that the more that you go to, the better you get. They come out of a training college with so many skills now that we never had when I joined, but they don't know how to apply those skills, and you only get that through operational experience. Your metabolic issues. It's not the sexy tossing weights around making calendar models. Like the general population, we're going to have to start to manage these people because they are a reflection of the general population. They're just a little bit more pointy, but they're getting fatter, they're getting less fit, they're getting more sedentary. All these metabolic issues. So we're seeing type 2 diabetes. We're seeing all these sorts of things that are coming into play that never used to be there. So again, it's a big area that somebody's need to move into. The diabetes and the cardiac risk that comes from that. And the last one that's there as well, and again, this is a challenge, and I don't for any second say that this is an insurmountable challenge, and nor is it one that we shouldn't be addressing, is that we're trying to increase the diversity of our fire services. In Australia, we're still very much just in the diversity means females. It doesn't, we've got a lot of other issues we have to work out, but in some areas, particularly my fire service did this a few years ago, we put quotas in place. But what you'll see, and you're probably seeing that across all these operational, particularly the police have done this a lot, in order to achieve standards and quotas, many of them can't meet the physical standards required of them to get into the job. So what they've done is they've realigned standards lower. And what we're seeing as a consequence of that is we're seeing a lot more injuries because we're adding people into that mix who should never have been there in the first place, rather than going out and saying, well, what physical attributes and characteristics would they be? Well, okay, they could be a CrossFit athlete. So let's go to the CrossFit boxes and try and find these people. They could be a rugby player. So let's go to the rugby players. So many of these challenges we have with getting the numbers purely come down to the fact we're attracting the wrong women. The women out there we need are there, but we need to do that. And at this stage, one of the big issues is we're still in the phase of let's get them in the front door, but nobody really has any concept of what we do with them once we get them forward. We did a study that went out about 2 or 3 years ago, working with your British Fire Service. So Emily Watkins down at Roehampton was involved in this, and it was 14 countries, 900 women. And all of them came up with the same issues. There's no pregnancy support for them. We don't give them PPE that fits. There's no strength and conditioning support. Menopause is becoming an issue in the British fire services. That's 20 years away for us, but it's coming. But we don't know. We're just not prepared for it. And even then, what the physiology of a female aging looks like compared to a male. We don't even understand what the men do, much less the women. So these are the challenges that are coming forward, and these are places where we need academics and we need the population like yourselves to really start to support us in developing this. Basic heat load as well. Again, going back into the fires. So we gain heat through conduction, radiation, and convection. We lose heat the same way. When they're operating, the ceiling can be above 700 odd degrees above your head. But on the floor, they can still operate around that 100 degrees quite easily. My PhD, we were lucky enough to have a special training facility we use where we ran it up to 100 degrees quite easily, and the guys and girls were just moving in and out of there as they go. As it develops, the smoke layer drops, reducing visibility to zero. So what you see in the movies is not our reality. It'd probably make pretty ordinary movies to show what we see, but you can't see your hand in front of your face. It's that black. And they will be crawling around on the ground. And what you see down below there is that's how we educate our kids. We teach them to get down low and go. That's where we're looking for the people. If they're safe, that's where they're going to be, and that's where our guys work. So my PhD study, which is where this data's come from, 124 professional firefighters. We only have a population at the time of only 300 in my fire service, so it's quite a considerable amount who came in. And they worked on a 20-minute standardized search task with a 10-minute passive recovery, which simulates our operational environment. So they go in for 20 minutes, they come out, change their cylinder over, get a quick drink and go back in. Using telemetry pills, heart rate, and also the perceptual stuff going forward. In terms of how hot they get, and anybody who's there before, I think there's nothing here that's surprising. They get hot. We've been there, done that, and it's one of my frustrations is that we're still in this space. The amount of people who are still just measuring how hot the firefighters get. I'm not even entirely sure on reflection whether I should have been looking at this data. It was always there, but anyway. So what's there is from what we're seeing here. Obviously they climb, and you'll see at the end of the 20 minutes on there, as they come out to rest, their temperatures continue to climb. They come out, they get a drink, they're still wearing their gear, but the temperature is continuing to climb throughout that rest period. And then what you see, particularly in that second 20 minutes, is where it starts to get a bit scary, is you start to see that real sharp increase in temperature going from there. Say Grenfell, those guys and girls were going in 5, 6, 7 times. So what does that graph look like if we continue for another cylinder and then another cylinder and then another cylinder? Of particular interest is that the ISO standard for occupational workers for heat, 38 degrees is the lower threshold, 38.5, they should never go back in. At 39, that's evacuate out. And you can see that even at the end of 15 minutes, moving into 20 minutes, within one standard deviation there, we're starting to see guys who should not be going in, but we don't monitor them. We have no monitoring capability. And part of that comes down to the fact that we have no real reliable way of measuring core temperature in the field. That is also it's also useful for our guys and girls. The pills are great, but the fact you got to take that 5 or 6 hours before, and that's sort of 80, 90 Australian dollars per pill per day. We're not doing that. They haven't got time to put a heart rate monitor as they walk out the door. All the measuring things that we use in the lab, we might as well throw them out because they're of zero value in this world. So how do you value add? By giving them the data they need in real time. A lot of them are now starting to work on the algorithms based on heart rate, those sorts of things. I can't overly comment on how accurate they are. I haven't sort of done that in the lab, but they seem to be getting better. But again, it's giving the workforces a solution that works for them, because they'll find a million reasons why your things are wrong. And as soon as you get to that point where you've given them a solution that they just think's an idiotic one that doesn't understand their world, then you've lost them and you might as well pack up and go somewhere else. Heart rates, again, nothing really revolutionary there. But when we're starting to look at the end of that second work cycle, the workload was standardized. So the only thing that's changed here is their temperature, their core temperatures have increased. So they're getting that higher thermal load, and we're starting to see them up around that 80-90% max heart rate. You know, when we're talking about 20-year-old firefighters, they'll do that all day and it won't worry them. But when we're talking about people who are in their 50s, who also have those other comorbidities that we're not managing, so their body fat's too high, they've got high cholesterol, they've got all these other issues that are starting to appear in their world just through natural aging. Running at 90% max heart rate is just, that's not good. That's where we start to see issues. And a lot of them as well, in terms of motivation, if they go in there at that time point and they see someone they need to rescue, they're going to go even harder again. So you've got to, we need to understand what can we do to keep that as low as possible, and how can we keep them at a point where if they are going to go into those really high heart rates, that their bodies have been physically prepared to sustain that. In terms of tasking of the crew, one of the things we do is it's based on our personal feelings of well-being. So we will actually ask them, how do you feel? Yeah, it's not a great, I'm not sure if I've put I have put the data there. So when we go to them, we'll actually say to them and say, how do you feel? Are you good to go again? And again, part of it's down to motivation, but the other part of it is, as you can see, the guy on the left there, he sprays the water on his head. He's happy to go. He feels good. He feels fine. While his core temp, we know from that other data, is continuing to climb. The guys on the right there, that's Grenfell. They're going to go back in, even if they know they're knocked up and they're knackered. They're hardwired that way that they will keep going. That's what we select them for. So you can't rely on that. And so what we did is we looked at these perceptual measures as well. And what you can see from there is, in terms of the strain versus the load, the dropping line, so the open circles, is their perceived wellness. So based on PSI and also RPE. And you'll see just exactly what I've kind of explained there, is that they'll basically track with their physiology until they come out and take their jacket off. And whilst there's a slight decrease in the physiological strain, if you ask them at that point, are they good to go? Well, as far as they're concerned, they're almost the same as they were when they started. But we know for some of those firefighters, they're in a position where they're starting to become dangerous to themselves. Well, they're high risk of cardiac event. They're at higher risk of slip, trip, fall. They're at a higher risk of just making a dumb decision because they're hot. So we can't rely on actually asking them. So any of you out there who are industrial engineers or whatever, if you can find us a solution that will give us real-time data on how they're going, that works within that environment, that's easy to use and doesn't get in their way, you're on $1 million there. You've got to work that out, and that's the next challenge that we haven't really got our head around yet at all. Post-fire rehab and cooling on the left there, that's pretty much what we normally do. Take your shirt off, have a bottle of water. A lot of services are doing their best to implement cooling. Unfortunately, sometimes they're guided by just really, really crappy science. And you'll see those arm cooler chairs there, and some of you may have seen them. The data we did when we looked at the cooling, you might as well not even bother. And the other problem is they have to put their arms in there for 20 minutes. They can't drink, so they're not rehydrating. So they're trying their best, and you're going to see these really crazy sort of solutions appearing. But what we looked at is how we could do this a bit better, and we started to use what we use in the athletic world. So 15-degree water for 15 minutes to the xiphoid process, and compared to the slush as well. So the 7.5 grams per kilo. Acknowledging as well, for those of you who haven't used slush, to get it to that slush consistency, it needs to have about 7% sugar in it. That becomes an issue again, because we're trying to manage the weight of some of these guys as well. So we can't be giving them a lot of this extra sugar just for the sake of it. One of the solutions we came up with would be a blender with a bag of ice, blend the ice into essentially a slush, and then just a little bit of electrolyte powder for flavor, or cordial, or whatever it is. it'll still do the same thing, but we have to manage that nutritional issue as well. And what we saw from those things there, so the open circle, I think is the, so the circle is the cold water immersion, so the black circle, the square is the slush, and the open circle is the passive control. And as you can see from what's there, the water and the slush were essentially as effective as each other. Obviously there's some variation within that, but the passive control still sees them at about at that 38 degrees after a 20-minute cooling process. In terms of what you would recommend, is it practical to have cold water immersion on a fire ground? Probably not. Is it practical to have a slush or some way of delivering slush on a fire ground? You're only limited by your creativity. It could be blenders back at the station, they have their slush already in a thermos at the beginning of their shift that they can grab and take with them. So that's a workable solution. In the training environment, however, water immersion is easily achievable, and we know that that's the best control. So why wouldn't we be using it in that training environment? But again, people at some point are going to come and ask you for your opinion or get you to interact with these, and you need to understand the two concepts, which is how good is it, and then you have to weigh that up with, well, does this work? And that's the key there. Last sort of thing we're looking at is the mental health, big issue for our people. They see horrible things, but again, when we combine it with the burnout, when we combine it with everything else we do to them, it starts to become a massive issue, and it costs a fortune. We came up with this theoretical model of what that might look like. When we took a lot of blood out of our guys and girls, we saw a lot of these increases in these pro-inflammatory cytokines that were there. So we're seeing an inflammatory response to the heat. We also see that from traumatic blast injuries for military. We see sleep deprivation. All these things will have an inflammatory type thing. Body fat, we know is an inflammatory. So when we combine that with an acute traumatic event, is that the straw that'll break the back? On the day, if they were fairly thermoneutral and they saw something happen, are they less likely to deal with it than they would be if they were hot? Because we know that we're now starting to see this inflammatory cascade really kicking off in them. So it's just a theoretical model. Cancer, right, I touched on that right at the beginning there. You see the photos up, and also the comic that's there. It's the old badge of honor that if your gear's clean, you mustn't be a very good firefighter. You've never done it anymore. Our gear now is bright yellow, and the reason for that is so that we can actually see the chemicals on there and force our people to clean it. It's the number one killer of fireys worldwide, whether in operation or post. And where they'll tend to get it, the main areas that we'll see is the protection will come through those flash hoods around the throat. Also, we know that as they get hotter, the pores increase, so there's a level of higher chemical ingress into the skin. So our flash hoods are being redesigned, and they'll also come up into the groin, up through the bottom of the pants. So as you walk, the pants sort of bellow, create a negative pressure, which will then suck it up as well. So we've got those issues there. So we're having to create those. We'll move into a model of post-fire decontamination. Luckily enough, in Australia, we have 3 sets. I've been issued 3 sets of gear, so my gear gets rotated very quickly. Particularly for the Americans, those volunteer, they'll have 1 set of gear. So it's going to get dirty. It doesn't get cleaned, and they'll have to clean it themselves, whereas ours is cleaned by industrial cleaners. In terms of how serious it is, though, most Australian fire services have presumptive legislation on our Workers' Compensation Act, and you'll see what's there, and they're limited, but that gives you some indication of exactly how dangerous being a firefighter really is. Going from these brain cancers right up to the non-Hodgkin's lymphomas and those sorts of things. It's taken a long time for us to get to that point, and almost all states in Australia are now there. My current understanding is British fire services just are not even close to this space. It's a big problem, and it's costing you a fortune, but that's the reason why the government's not acknowledging the fact that cancer is a problem. So that's why we need to start to understand, can we develop gear to protect them? Yes, we can. That was that Gore-Tex membrane, but then and if you come into this world as an occupational physiologist or thinking in there, what are the knock-on effects and how do I mitigate those? So we put the Gore-Tex in, okay, now the gear's heavier, slower, harder to move. Okay, well, I've got to get them fitter and stronger to deal with that. Now they're getting hotter. Okay, well, how do I put in cooling interventions? How do I make them more robust to work in the heat? That's the area where science can really start to play a role now. Challenge to fixing the problem. Obviously, you've got those two competing issues all the time. Your work health safety guy on the side there will always tell you to reduce all risk. You can't do that. It's a dangerous environment. But then you also have that clown on the other side who, is basically the gung ho. Let's get in there. We're heroes. That's how they measure it. We need to go into that common sense role there. How do we make up the difference between the two? And the other thing as well, and this is just, if you ever want to work in this world, it's a tip to keep in your mind there. The two things that firefighters hate is exactly that. It's change and the way things are. So they'll bitch and whine all the time and chew about how everything's broken and how everything's wrong. But when you come to them with a solution, guess what? That's going to be even more wrong than the old solution. So be prepared to lose a lot of bark if you want to work with these guys and girls. So that's kind of that's me done. My contact details are there if anyone wants to have a chat. More than happy to. And I'll go back to you, Jeff, and try and work out how to get rid of this.
Brilliant. Thanks very much, Anthony. That was brilliant. Really, really informal, and it's good to hear about all of the different aspects which you have to attend within your job. We're sort of short on time, and there's a couple of questions that people would like to ask. So Irene has asked about the health and the well-being of the fire service and what training they have to support them with certain psychological impacts that they've had happen during their time in their career. So how do you support them with the trauma, fatigue, burnout, etc.?
So to be honest, we're actually really in the infancy of that within this industry. Our health and wellbeing, particularly, so I'll address the mental health first. We're very big on the peer support model that's there, and fire services in particular have really led the way there with these peer support models supported by psychologists. Our biggest services like New South Wales Police, they'll actually have full-time psychologists on site who'll assist with those. And we also have what we call a critical incident stress management debrief, whereby at the instigation, so I as an officer, we go to something horrible, I instigate this straight away, which is the peer support, and then in come the psychologist as well to then support that. The challenge now going forward, though, is how we then support it in terms of the physiology. So how do we keep them exercising? How do we keep them working with nutritionists to try and build a little bit of robustness? And mental health first aid is something we're sort of working on now as well. So, yeah.
Brilliant. Another question that's come out from a couple of people, and something I thought about myself. You obviously spoke about core body temperature and how you measure that, and how it's quite difficult to do that in the field and potentially in training due to cost. What about the estimation of potentially heat storage capacity, potentially using heat tolerance testing to identify which of the guys and girls should be going out in the fire and which shouldn't be? Is that something that you use at all?
We don't, and a lot of it's purely because of the fact we just don't want to play in science. But a lot of it's so variable in our world and what's there. When you, as a concept, it's definitely right, but on any given day, their thermal tolerance will change. Beginning of summer, like this time of year for us, is probably our most dangerous because the temperature's in there. It's in the 20s. You go out there and it's a little bit hot, but you're there. But if we get a 30-degree day, which we might get in a couple of days, that's when they'll fall over. But by the end of summer, they're more heat acclimated. They're better off. When we pick them up, like we have a deployment model, so we'll pick up our firefighters and move them around the country. If I pick you up right now at a Canberra at 20 degrees and drop you in tropical North Queensland, it's 35 degrees and 70% humidity up there. It's very variable between areas, and that's why we're really focusing on the education pathway for our people. How to understand what's happening to them. What are the signs they're coming along? We definitely like to be able to give them that level of interaction, which would be, this is where we think you can do stuff. It's just really practically very hard with them. And just the logistics across, so New South Wales, you could see there, they've got 300 odd fire stations dotted around a state that's twice the size of the UK. How do you get to them? So there's those logistical issues as well.
suppose it's interesting you sort of mentioned about heat acclimation at the start there, because that obviously, like you say, can alter their heat tolerance in some way. Is that something that they try to utilize before the hotter seasons to try and acclimate them where they can, or is that just not logistical at all?
It's just not cultural. It really isn't it's a cultural change we're starting to see. We're having to move out of the old hard head firefighting, and they're still in the world. The problem is they're our senior managers now. We're slowly flushing them out, and we'll get better and better at doing this, but we need to make a start somewhere. So yeah, it's just a cultural thing. We're just not having any wins there.
Of course. And just bearing on time, I've got one more question just in relation to kind of your overall experience of being in the fire service. So you've obviously started, you sort of mentioned at the bottom, have worked your way up to this position that you are in now. What have been the biggest changes that you've seen in regards to safety, which you felt have helped you in your career moving forwards?
Safety. Well, again, the PPE we wear, and as much as I've sort of painted a picture of how bad it is for us physiologically, it's so much better than when we started. It's so much safer. I can go into a building quite comfortably, into a long way into a burning building, and be quite safe doing that. We have thermal imaging cameras so we can see through smoke. When I first started, we were training on these things called guidelines, and it was basically like a cup and string. You'd walk in the building and you'd have to just lay this string out behind you and work your way back out. We would use thermal cameras now to do that sort of stuff. So even in 15 years, we've moved light years away. To some extent, our work health safety, I don't know what it's like in Britain, but it's become so strict. It's a real pain in the ass for us. It's gone. So we have fire trucks now that we're not allowed on the roof of, in case they fall off. And the irony is we pull a 10-meter ladder, a 9-meter ladder off it and stick it up against a burning building, but that's okay. But because of work health safety, because it's above 2 meters, we're not allowed to stand on it. And now we have these knock-on effects where we have shoulder injuries, lower back injuries, as people still have to get things off the roof. So wins and losses everywhere.
Of course. Brilliant. Well, thank you very much, Anthony, for your time. Really appreciate it.
Not a problem.
The presentation's been recorded, so it will be available for you all to re-watch. Our next seminar series is November the 18th, 3 till 4 p.m. And we've got Dr. Francis Quinn from Robert Gordon University who's going to be talking to us. So yeah, thank you once again, Anthony. And everyone is free to go.
Thanks so much, everyone. Thanks, Anthony. Thanks, Jeff, for